Welcome back to Connect and Transform. We're continuing creating a game of checkers in an SVG right where we left off. Last night I reviewed the code and I found a couple places where maybe I was going too fast and I missed some things. And then there's also some code where we were using a temporary solution and now we need to go back and do it properly. One example of the temporary solution is in these 4 jump animation functions, where we were jumping a red piece over a red piece just for testing out the animation. And here in the code, we need to get the ID of each piece in order to target the right element in animations. And we're setting the jumped piece, we're setting the last portion of that where it is the red team or the black team, the string red or black. We're getting that from the piece that's doing the jumping. So that's good enough for demonstration purposes, but it's not correct logic. So we do need to get the string red or the string black that is the opposite of the current piece, because when you're jumping a piece, you're not jumping a piece on your own team. So we're going to create a function called getOpposingTeamName. And we're going to append this value instead of the substring of the current piece for all 4 of those functions. So now we need to create a function with this name and implement it. Okay, so we've created it. I think I'm going to get rid of some of these functions that we're not actually using, just to clean up the code. We will use the turn change function, we will use this function, and we will probably implement these 2 in a future video. So let's look at getOpposingTeamName. So that's going to be based on the current turn. Basically, all we're going to be doing is returning the opposite of whatever the current turn is. So if the current turn is red, we're going to be returning the string black. Otherwise, we're going to return the string red. And we are calling this function from the jump animation functions. So I'm going to go ahead and tab that over so it's not all the way on the left. I'm just going to refresh real quick and make sure that we didn't break anything. We're looking good. There were another couple things that I noticed. So in the function rPiecesAllies, the intention was to say if ID1 contains black and ID2 contains black, then they are on the same team and they are allies. So we return true. What I was missing is I want this to say if ID1 index of black does not equal -1, meaning that it is present. And I want that to be the case for all of these calls to index of. There, so we fixed that. There was another issue in the very next function checking for whether a piece was kinged. We have a query selector where we were passing in the ID. We want to precede that with a hash symbol so the query selector knows that we're talking about an ID as opposed to an element tag name. So we fixed that. There was also a slight change when looking for jumps here. I ended up simplifying, at least I believe it's simplified. So this is piece present at location. This returns either false or a piece. And so I ended up using this function in place of the other one. So where we're checking if 2 pieces are allies, instead of getting the piece from the board square, I'm just checking if a piece is present at the new location. So it's basically doing the same thing, but it's doing it in a different way. Okay, let's refresh, make sure we haven't broken anything. We have not. one final thing that I noticed is I had copied and pasted this ID into multiple places, so I'm going to remove it from the places it is not needed. Now let's look at all these text elements here. The current turn in the JavaScript, we were initializing that to the team red. So I'm going to go ahead and just put red in there. And then the moves possible, let's initialize that to 0 just to have some value there. And then the other thing we need to do is we probably need to hide the winner section until there is actually a winner. So we're going to give both of these text elements related to the winner some kind of ID that we can use later in the code to affect it. We're going to hide the label with opacity equals 0. And then in the code, we will change that to 1 when a winner has been discovered, and we will initialize some value here when a winner has been discovered. Another thing we're going to do is we're going to give each of these winner text elements the class name winner, and that will allow us to target these specially in the CSS. Let's go up here to the CSS, text.winner, and we're going to make these red. And we're also going to make them bold. So I'm going to go ahead and save, refresh, and we no longer see the winner section, at least until there is a winner, and we see initialized values for current turn and moves possible. Okay, so the next thing is we need to actually work on implementing updates to the information box, and then we need to implement actually changing the turn. So let's look at the turn change real quick. So the turn change is going to be pretty quick. It's basically going to toggle the current turn, and then if it's the machine's turn, then we're going to make a call to auto move. So the first line here will just be an assignment. So we're going to say if current turn is red, then we're going to set current turn to black. Otherwise, we're going to set it to red. And then here, we're going to say if the game mode is human machine and then current turn is equal to black, because I'm assuming that when the human plays as red. So if the human has just played and turn change has been called, then current turn has already been toggled from red to black. So we've just finished the human's turn. Now it's the machine's turn, and we're in human machine mode. So we're going to call auto move with an auto move delay. Okay, then there's a second condition where we might need to call auto move. And that is if the game mode is machine machine. And I believe that's it for turn change. So as soon as we call turn change somewhere in the code, we'll tap this over, but for now we'll leave it here. Same with update information. Okay, so let's look at auto move now. Auto move calls apply move. So we're going to have a new function here under apply move, which is going to be called advance move. Like you're advancing it forward. And we're going to pass the move that we selected to execute, which is one of these 8. We're going to pass that forward into the advanced move function. And what the advanced move function is going to do is it's going to handle the logic around calling the promotion to a king animation and calling turn changes. And it's also going to be the callback to auto move. So one thing we want to do is we don't want auto move to call itself, because instead auto move is going to call apply move, which is going to call advanced move, which may then call auto move if appropriate. So we're taking this tight loop and we're making it into a little slightly bigger loop. So advanced move, we're going to be defining a couple of constants to use in our logic. But the very first thing we want to do is we want to make sure that all of the animations are completed before we actually switch turns or king a piece or do anything of that nature. So the first couple lines here, we're basically going to be checking if an animation is in progress, and if it is, we're going to exit the function and not create any side effects, but first we will call ourself in the future. So this function, advanced move, if there's an animation still happening, then it will call itself. An advanced move is being given a move. We're going to call this old move, and I'll explain that in a moment. And then we need to make sure to pass that forward. Okay, and so this if statement, we're saying if an animation is in progress. So that's going to be if the transition queue length is greater than 0, or the flag transition in progress is true. So if there's an animation happening, then we're going to call advanced move at some point in the future, and we're going to immediately exit. And then the next thing we're going to do is we're going to have a couple of constants. So we're going to have one for just kinged. That'll be some expression. We'll get back to that later. We're going to have one for just jumped, and we're going to have one for whether or not we can continue a jump. And then using those constants, we will determine which functions to call out to. So the first thing is, if we were just kinged, so if we were just kinged, then we're going to call the king me function. And that one does not take any parameters. Let's scroll down real quick and look at the king me function. We're going to add a condition here. So if you're already kinged, we're not going to do the king me animation again. Is piece kinged? Okay. And then we need to pass selected piece there. Okay, so if we're already kinged, we're just going to exit. We needed to either put that logic in the king me function, or we would have needed to put it here. So I chose to put it in the king me function so that we can just call it from wherever, and it should behave the same. So if we were just kinged, we're going to run that animation. Another thing we need to say is if our turn has ended, we need to call turn change. So let's think for a moment about under which conditions our turn has not ended, but where we have already called a move. So we've already applied a move here, one of these, and we need to think about the condition under which our turn is not over. And so that would be if you were not just kinged, and you did just jump, And you can continue that particular jump. So if all of this is true, then your turn is not over. Otherwise, your turn is over. So we'll say else, and then we're going to call turn change. Okay, so that's where we call the actual turn change. We're going to update information as well. So now we're calling each of these functions that we'll need to go finish implementing. And if your turn did not change, then we may want to call auto move if it's the machine's turn. So basically, if it's the machine's turn, then we're going to call auto move. Okay, so how do we know if it's the machine's turn? Well, it's the machine's turn if the game mode is machine-machine, or the game mode is human-machine, and the current turn. Now let's think about this. So we have not yet changed the turn. So if it's the machine's turn, then this would still be black because it would not have toggled back to red. Okay. And then auto move or advanced move was called by apply move. So we're going to tab this over. We do need to come back and complete these three constants. We'll do that in just a moment. I just wanted to point out that turn change and update information have both been called. So since turn change has been called, I'm going to tab it over. This one still needs to be done. We'll come back to it. Okay, so let's look at these three constants. And I think I'm going to start with can continue jump. So if you can continue a jump, then by definition, you must have just jumped. And then we're going to say get all moves for all pieces dot filter. So we're going to filter all possible moves from this point forward. And it is from this point forward because this function advanced move doesn't do anything until we've waited for all animations to complete. So anything that was in progress has completed. So we're going to get all possible moves from this point forward. We're going to filter them to only jump moves that begin from the place where our most recent move, which is old move, where this one ended. And then after we filter that, we're going to make sure that the length of the result must be greater than 0. Okay, because if the length of filtering the possible moves was 0, then that would say there is no possible move to continue this jump, and that's what this expression is looking at. Okay, so now let's look at what the filter is going to be doing. So we're going to call this new move. Okay, so first we're going to check that the action is a jump. So to do that, we'll say new moves action must have an index of jump, capital J, that is equal to 0. Okay. And then we're also going to check that the new moves source has the same X and Y position as the old moves destination. So we're going to say new move source, and the source here is the ID, which is a string. So we're going to take a substring. And if we want both the X and Y components, that's going to be locations 2 through 5, 2, 3, and 4, which would be X underscore Y. And we're going to validate that the new move's source must be equal to the old move destination, and then the same substring 2 to 5. And that will do it for whether or not we can continue a jump. Now let's look at the definition of just jumped. So that would just be if the old move action, I shouldn't have pasted that line of code in, that just got in my way. So if the old move's action contains jump, so dot index of jump, capital J, equals 0. So what that's saying is if the old move was jump piece northwest, jump piece northeast, etc., then we did just jump. And then finally, just king, we would be looking at the old move's source and checking whether or not that is kinged. Now remember, we haven't called the king me function yet. So technically, it doesn't really matter whether we look at the source or destination, but because the href will not contain kinged. So we'll say not is piece kinged, and we're going to pass it the old move's source. Actually, we're going to do the destination because all the animations have completed. So at this point, the piece is actually at the destination, not at the source. So we're saying that after this move is done, the piece is not kinged. So now we need to check for the condition where we're either on the red team and we've reached we've reached a Y position or a row of 0, or we need to check that we're on a black team with a Y position of 7. So in the first case, we'll say if the current turn is red and then we want to say that the Y, and we'll get back to that, equals 7. I'm going to use the character 7 versus the number because we're going to be comparing basically a character, a substring out of the ID, and that ID is going to be old move dot destination. So in other words, where the piece ended up, dot substring. And then this would be 4, 5. Okay, so I'm going to copy this entire condition for red here. Oh, and actually red can be promoted to a king when its destination row, when its Y position is 0. And then for black, it'll be when its Y position is 7. Okay, so I think that'll do it for that definition. Let's scroll up here. So we do still need to update information. But real quick, let's just save that. Let's refresh here and make sure we don't have any errors. We do not, so that's a good sign. Okay, let's update information real quick, and then we'll do a quick demo, and that should do it for the video. So updating information, we're pretty much going to be grabbing current turn, moves possible, and then we're going to want to check for a winner maybe and update those labels. Let me grab this info current turn ID. I may have missed, we're getting down to where there's less stuff on the left and I scrolled right past it. So here we're going to say document query selector and this will be that ID. dot text content will equal something. And then let's grab the other info box that we need to update, moves possible. Okay. One thing I'm going to do here is we have this variable for possible moves, but I know that we use that in a lot of other functions, including this get all moves for all pieces. So I'm going to change the global variable. Um, so I'm going to change the global variable to allowable moves. And so here, before we return something, I'm just going to set allowable moves to be equal to whatever we're returning dot length. And then that's going to be possible moves dot length. And then we need to update our global variable to use this new name so we don't have things stepping on each other. And then we can go back to update information, and under moves possible, we'll just say that that is the allowable moves. So now here for the current turn, that's just going to be the current turn variable to uppercase, let's say. And then we're going to check for a winner and update an endgame screen. So we'll create another function here. Now this function, update information, was called earlier, so we're going to tap that over. Let's save that. Let's just refresh real quick and make sure we don't have any errors. We do not. So we may get to this one in the future, but real quick, I want to do a demo. So I want to click on machine. And okay, I misspelled JSON.stringify. It's always the dumb stuff that gets in your way. So let's scroll down here, 308. Okay, so now we've got the correct spelling. Let's refresh this. Okay, cannot read properties of null, 137. So we're calling isPieceKinged on something that is null. Let's just give that a try. Okay. And there we have it. Both sides are playing. They're jumping when they can. Let's just watch this through to the end. I know it'll be a little long, but most of these videos have been very boring. So there we go. We see a kinged animation. And we also saw that when that black piece became a king, its turn ended and we immediately shifted over to the red. And we also saw there that when the black king jumped, it did not continue moving, so it knew that its jump was over. We also saw the king briefly move in both directions, forward and backward, before it was taken. And I would expect that we will see some kind of error whenever one side runs out of pieces, because we haven't finished defining the endgame state, and it will continue trying to call these loops until something fails. And it looks like the game is going to take a little longer than it could have. We'll also note that the info box here is updating with the current turn and the moves possible. because we're just choosing a random valid move at this point in time, there's nothing that gravitates the pieces towards each other. There's nothing that uses any sort of strategy. But given enough time, they will eventually meet and there will be a victor. When the red king is on an edge like that, it only has 2 moves. So it's going to take a while to get to the center of the board, but then eventually, once it's in the center, it has 4 options, and so the chances of it getting stuck is a little bit less. Basically, when the red piece is against the edge or in a corner, it is more likely to get stuck there, and when it's in the true center, it's more likely to stay in the center. Okay, this game's got to end fairly soon, I would think. There we go. Okay, so we're going to jump the red piece. And yeah, we got an error because we haven't defined this. I think that's where we're going to... No, actually, we're not going to end the video there. We're going to finish creating this last function. Okay, so checking for the winner and updating the end game screen. So I think the first thing we're going to do here is we're going to make sure that all the animations are completed. So we're going to copy that bit of code and paste it there. Okay, so when all the animations are done, yeah, we're just gonna be calling our own function here until all the animations are done. So just like that, and we can do min delay, that's fine. Okay. So now at this point in the function, all of our animations are completed. So now we're gonna say if get all moves for all pieces, dot length is 0. In other words, if your team has no more moves, okay, so we're going to say if the current turn is red, so if red has no more moves, then the game winner is going to be black. Otherwise, if the current turn is black and you have no more moves, then the game winner is red. Okay, and then we're going to have a couple more conditions here. So we're going to check for, rather than looking at the number of moves, we're going to look at the number of pieces. So if, and then this is going to be document.query selector. So we're going to be looking at the pieces container, looking for use elements with a class name of piece and a class name of, let's say, red. So if this dot length is 0, then the game winner is going to be the opposite team, black. And then we're also going to be looking for black pieces. And if there are none of those, then the game winner is going to be red. And then if there is a game winner, now this is where we want to show our text. So we have this info winner bit of text here. We want to update the opacity to 1. So document query selector dot set attribute. Opacity to 1. Okay. And then we're going to take info winner label element, and we're going to set the text content. And that is just going to be the game winner, probably 2 uppercase. And I think that'll do it. So, okay, so we're calling this function from update information. So we'll tab it over. Let's save, refresh, and we'll watch one final demo, and then we'll close out the video. It makes for a good screensaver. It's kind of entertaining to watch. We got the multi-jump there. Okay, 1v1. And there we go. Okay. And it actually failed. Line 169. Okay, so I have a little bit of work to do. Okay, so if this query is null or length 0, then the game winner is going to be black. But I think what I'm going to do is maybe I'll just do that. Although I thought that the query selector would just return an empty list. I'm hoping I'm not missing something here, but let's run this again. Multi-jump. Another multi-jump ending in a king. Okay, so now we did see winner red and there's no errors. So that was at least one initial demonstration of machine-machine game mode completing all the way to the end. In a future video, we'll work on refining the UI and adding a human mode so that we can have a human-human game mode and a human-machine game mode. But that will do it for this video. Thank you for watching.